Alright, so here's a run through of this day 0 warm-up video. Um, I would say this is a review of stuff from before Christmas. So if this doesn't make sense to you and you want some more examples, go back to all those videos I have before Christmas time on vectors and components and stuff like that. But what's cool about this is, and the reason I moved day 0 to the second day actually, is because this is the only trigonometry you need to be able to solve all our problems in this class in engineering with our truss calculations. So if you don't understand any of the other stuff from before Christmas, you have to understand this to be able to do these problems. Because we just spent a day on doing external forces, we need this skill to be able to do internal forces. Okay, so it's not bad. I gave you the shortcut way to do this, and that's the way I'm going to do it from now on, even though I went into a longer math answer earlier. But if you ever have a diagonal force, so this is a 45-pound force that if I gave it sense, it goes up and to the right. It's a 64 at a 64-degree angle. Now, what's weird is, remember how we want our forces on bridges to balance, like all the ups have to equal all the downs, all the lefts have to equal all the rights, otherwise you have a moving bridge, and a moving bridge is not a bridge I want to drive on. So, whenever you have a diagonal force, think of a force on a beam, and beams are rarely straight up and down in our triangles. Sometimes they are, but when you have a diagonal force, you have to split it into how much of that 45-pound force is pushing sideways and how much of that 45-pound force is actually just pushing up. And if you think about it, a 64-degree angle, to me, 45 is like splitting it down the middle. If you had a 45-degree angle, you'll get the same amount of force pushing sideways as up. But if I have a 64-degree angle, I expect a bigger answer for how much of this 45 is pushing up than I get for the horizontal part. So I expect CY, my force of C in the Y direction, to be a bigger number than my force of C in the X direction. That's a good thing to know ahead of time, just plain common sense. Okay, so how do I find the X part? Well, I kind of said it before. You always take the diagonal times cosine. Oops, it's cosine, but you take, I think I can erase this pen. Yeah. You take the diagonal times cosine of your angle. And that's it. And then whatever the answer is going to be your answer. Now, one thing to be careful of, if you're on a scientific calculator, it usually defaults to degrees, but if you're on a graphing calculator like this one, make sure you hit mode and check that you're in degrees. Okay? I know I've said that in a few videos. So all I got to type in is 45 times cosine of 64 degrees. And since I'm in degrees, I just type in 64. And I get 19.73 is good enough. 19.73. I'll just say, let's go 2 decimal places unless you're told otherwise. Okay. Now, that's how much of this force goes sideways. Okay, so its X part is 19 pounds of force, and its vertical part, remember, I expect it to be a bigger number because it's 64 degrees is pretty upward direction. And if you want the Y part, you use sine. If you want the math explanation for that, go back to the previous videos. If you want the quick and dirty engineering explanation, just remember sine goes for vertical, cosine goes for horizontal. So I type that in, and I get 40.45 pounds. So I do get more force going up than sideways. Now, some people might be confused because you might think, shouldn't that add up to 45? No, it shouldn't. Because it's more of like it's a right triangle thing. So you could do a squared plus b squared equals c squared, and it would work out. So that's one thing you need to be able to do in trig in these problems, is be able to take an angle force and turn it into its horizontal and vertical parts. The other thing you need to be able to do is be able to take the horizontal and vertical parts and figure out the diagonal force and its direction. So you know how we started with the diagonal force and its direction, and we split it into its horizontal parts? Well, I need to be able to do the reverse of that. So we did it forward, we're going to do it in reverse, because I'm starting with the x part and the y part. So first of all, I'm going to sketch this, and we said it before. Once again, you can go back to the old stuff if you need to. That when you draw these, the resultant vector means the vector, once you put a couple forces together, you always attach them tip to tail. So if I'm going to draw what this vector actually does, if I'm pushing 40-pound force to the right, why do I say right? Because it's a positive number. And if I'm pushing a 12-pound force down, what direction is it actually going? Well, it's going to be going down and to the right, but how much down and how much to the right? Well, I'm going to try to draw this. Let's say I was starting at this point here. I'm going to try to draw this with the sizes in consideration. So if I go straight sideways and 40 pounds to the right because it's positive, and then my y, if it was positive, I would go up, but since it's negative 12, I'm going to try to make this a smaller vector because 12 is smaller than 40. Now you'll notice I didn't write a negative 12 here because when I draw it down, it's implying my direction. And then where would you actually think of this like a rock? If you pushed a rock sideways at 40 pounds force and down at 12 pounds force, where would the rock actually end? It would actually travel in this direction. It would go straight diagonal. So this guy here is my resultant vector. And I need to figure out two things about it. I need to figure out, one, what's the size of this, and two, what is the angle here? Okay, I'm going to put a theta. A theta is like a zero with a, it kind of looks like Saturn. Okay, so how do I find it? Magnitude is the size. So it's Pythagorean theorem. You got a 40 and a 12, so you're going to do the a squared plus b squared equals c squared. Just make sure the c squared is what you're looking for, and that's vector d. And a squared is, oops, sorry, it's squared still. A squared is 40 squared plus 12 squared. You could put a negative 12 when you square it. It turns out positive anyway. And then you're going to square root your answer. So vector d, the size of vector d, I think in math when we do the size of a vector you do this, but I don't know, that's not really important right now. I'm just going to do square root of 40 squared plus 12 squared inside a big old square root sign, and I get 41.76 pounds. So instead of pushing 40 to the right and 12 down, I could push with a 41.76 pound force at what direction? Now this is the other thing, and this is the only time you use inverse trig. You're going to use inverse trig to find angles. If you know the angle, use regular trig. Like here, I knew 64 degrees, so I used regular cosine and regular sine. Down here, if I'm going to find an angle, I use the undoer of sine and cosine, which if you look on your calculator, it's right above. See that sign with the little -1? It actually means the inverse sine, inverse cosine, inverse tangent. So remember SOHCAHTOA, right? SOHCAHTOA. I have opposite and I have adjacent. The only thing I don't want to use, I could use this answer, but it's already rounded, and if I round a rounded answer, it's not going to be good. So if you ever need an angle, you should already know the opposite and adjacent, and I'm going to do the math here, but tangent of my unknown angle is opposite the y part over the x part. Is it always y over x? Heck yeah. So to undo it, you just use that fancy inverse tangent button on your calculator. For those of you who are getting bogged down with the trig right now, just know that for magnitude you always use Pythagorean theorem, and for direction you always use inverse tangent of y over x. Always. Always. Okay, so on this problem I just have to type in, and make sure you're in degrees, but we already are. So I just have to type in inverse tangent, so I hit second and then the tangent button and see how it comes up, like that, of 12 over 40. And it makes a 16.7 degree angle. I always just go one decimal place on degrees because it seems like ridiculous to go that accurate on an angle. And does that make sense? Does it make sense that it's a 16 degree angle? Now, you could write negative 16, I'd be cool with that, because it is down. But does it make sense that it's pretty horizontal? Yeah, the horizontal force is way bigger than the vertical force. So that's a recap of this stuff. Hopefully that makes sense, and you'll use it on your day 2 stuff. Okay. Later, people.